If the human body temperature is 98.6 degrees, then why does a 95-degree day feel scorching hot instead of nice and cool? For those of you who actually paid attention in biology class, this answer should be pretty clear. Like having X-ray vision into how our bodies work, our bodies are constantly generating heat. Biochemical reactions in our cells produce heat. Your brain and every internal organ produce heat. Even physical activity, like dancing or working out, produces heat. Essentially, the human body is a walking boiler. All that food you eat, the burgers, steaks, tacos, and wings, is just fuel for the fire. Since the boiler never stops running, maintaining a steady temperature of around 98.6 requires a constant release of heat to keep everything in balance, and the body's primary radiator is the skin. The 98.6-degree figure we often cite actually refers to our core temperature, or internal organ temperature. If you were to use a thermometer rectally, that reading would be very close to your true core temperature. It's the real heat of the inner body. But your skin, the organ responsible for cooling you down, isn't actually at 98.6 degrees. It typically sits around 91 to 95 degrees. Anyone who studied high school physics knows the second law of thermodynamics. Heat only flows from a hotter object to a colder one. So when the outside temperature hits 95, it's essentially the same as your skin temperature. With no temperature gap, it's incredibly hard for your skin to shed heat. Your body then has to rely on sweating to stay cool. But if the humidity is also high, and the air is already saturated with moisture, your sweat won't evaporate. And if it doesn't evaporate, it can't carry heat away. In that case, you're just leaking water without actually cooling down. So while 95 degrees might sound manageable, it's actually not refreshing at all. Not everyone handles the heat like a pro. Extreme heat can be brutal for anyone. Basically, at an outside temperature of 95, your skin effectively stops shedding heat, which is why you feel hot. We've all experienced this in daily life. At 95 degrees, you're miserable, uncomfortable, and restless. But at 77 degrees, you feel absolutely perfect, like a breath of fresh air. So the temperature that truly feels comfortable to us is actually around 77 degrees, not 95. Why is that? Well, as we know, the body's thermostat is the hypothalamus. If your temperature gets too low, it constricts your blood vessels and makes your muscles shiver. But if your temperature is too high, it dilates your blood vessels and triggers sweating to speed up heat loss. When the outside temperature is around 77, there's roughly a 15-degree difference between the air and your skin. At this point, your skin can shed heat smoothly through natural radiation and convection. The hypothalamus doesn't need to do any extra work. It can just kick back and relax. We all know how great it feels to catch a break at work, and your brain feels the same way. When your hypothalamus doesn't have to stress, your whole body feels great. To sum it up, 77 feels comfortable because your body is losing heat at the perfect rate. 95 feels hot because you're not cooling down fast enough, forcing your brain to step in. By the same logic, if it's below 68, you lose heat too quickly, which is why you feel chilly. This brings us to another cool point. The sensors in our skin don't actually feel temperature itself. What they really feel is the rate at which heat is leaving our skin. The faster that heat escapes, the colder you feel. The slower it leaves, the hotter you feel. Think of that classic physics problem. Touching a piece of iron versus a piece of wood in the winter. Even if they are at the exact same temperature, the iron feels much colder to the touch. Why? Because metal is a great conductor. It sucks the heat away from your hand instantly. Since that heat escapes so fast, your skin registers it as being freezing. Wood conducts heat slowly, so you don't feel that same chill. It's the same the other way around. Metal at 140 degrees will feel way hotter than wood at 140. In short, what our brains perceive as hot or cold is actually the speed of heat transfer, not the temperature of the object itself. Mind-blowing, isn't it?